All right, so now we're multiplying square roots, but we have variables to take care of too. Notice our two steps haven't changed. We're still multiplying coefficients and then following up with our product rule. The numbers underneath get multiplied separately for the numbers on the outside. And then we're going to simplify. There's just going to be some extra things to keep in mind when the variables get involved. So let's start by multiplying. Notice I do have a coefficient on my second radical. I don't on the first one. So 5 times 1 is just 5. Underneath the radical, I have to worry about the 6 and the 8. 6 times 8 will be 48. And then we have to keep in mind our product rule for exponents as well. Let's make these blue. X to the 4th times x to the 5th is x to the 9th. When multiplying those powers, we add the exponent. So there's two different games that we're going to play here. First, we need to simplify the 48. Since we're talking about square roots, we need the biggest perfect square. So for 48, the biggest perfect square is 16. Again, the reason we picked the 16, it is a perfect square, and it evenly divides into 48. 16 times 3 gets us 48. So that can help us simplify the number, 48. Unfortunately, x to the 9th, we have to play a bit of a middle school game. So when we're thinking about this radical, this is a square root. We never write the index, but that index is 2. So in order to simplify a radical when we have variables involved, we have to think about that index. How many times does 2 go into 9? Well, 2 goes into 9 4 times. So 4 of those x's are going to come out. There's still a 5 as a coefficient. There's going to be a 4 coming out of the radical because the square root of 16 is 4. And then 4 x's, and x to the 4th power, come out of the radical because 2 goes into 9 4 times. So what's going to be left behind? There's still a 3 that's left behind. The square root of 3 is not a nice number, so it stays under the radical. And remember, 2 went into 9 4 times, but there's 1 left over. 4 times 2 is 8, but we had 9 of them, so there's still 1 hanging out under the radical. We don't usually write that power of 1, but if it helps you to focus on the work, if it helps you to see where things are coming from, feel free to do so. We can still clean this up a little bit. 5 times 4 is 20. We still have an x to the 4th and a 3x left under the radical. Definitely a more medium level problem here. Because we have to deal with those variables, there's just some extra stuff to be careful with. Let's take a look at a cube root example, and then I'll go ahead and cut this video off. We'll break this one into 2 videos. Notice we have 2 cube roots here. What's nice about this one is no coefficients. So we're not looking at something too crazy just yet. So we want to multiply the numbers underneath the radical. 54, let's stick with red. 54 times 5 is going to be 270. And then multiplying the variables together, m to the 8th times m to the 4th, that is m to the 12th. Again, to multiply those powers, we're adding the exponents. So we can simplify this one. 270, if you're not as comfortable with your perfect cubes, remember this cheat sheet is here to help you. We're talking about cubes here. So we want to find one of these numbers that divides evenly into 270. Conveniently, it's going to be 27 times 10. So we can break that 270 up into 27 and 10. Again, the 27 is the perfect cube. That's the important one. That's the one that came off of our table. The reason we have the 10 there is because 27 times 10 gets us to 270. M to the 12th, we're back to playing that middle school game, but now the index of our radical is 3. And we write the 3, unlike the square root where we don't write a 2. We do write the 3 when talking about cube roots, so we know which kind of radical we're talking about. So the question we're asking is how many times does 3 go into 12? 3 goes into 12 4 times, so an m to the 4th is going to come out of this radical. Putting all of this together, the cube root of 27 is 3, and and m to the fourth comes out of the radical, again, because 3 goes into 12 4 times. The 10 is left behind. Cube root of 10 is not a nice number, so we just bring it down. And there are no m's under the radical because 3 went into 12 exactly 4 times. This might be a good question for a what if. Ask yourself, if it was m to the 13th or the 14th, how many m's would be left behind under the radical? If you're having some difficulty with that question, maybe you should raise your hand and definitely ask about it, throw some what ifs out there before moving on to the next couple of videos. They will certainly get spicy from here.